Hey, welcome to our first lesson. I know you're excited. We're in lesson 3. That's where we're going to start. I know that's kind of weird because it's the first lesson, but we're going to lesson 3. I think some of the things taught in the first 2 lessons we can hammer out in lesson 3. We're going to start on page 25. So you're going to have to keep your eye on the screen. I'll put a page number generally when we're going through the book because we will have to skip around sometimes. Today we're going to learn about equivalent forms of functions. Hopefully you remember what a function is and what a relation is. These should be review. And we're going to use tables, graphs, and equations to analyze these functions and make predictions. And then in the next video, I'm going to make 2 videos here for this lesson. The next video, we'll figure out if they are equivalent by doing some algebra, but we'll talk about that later. We're going to start on page 27. You need to turn to page 27 and complete numbers 1, 2, and 3. And yes, you actually have to do it. You have to complete it. It's not an option, and this is what you do. We're going to engage your brain. Please turn to page 27 and complete numbers 1, 2, and 3. Should be review. And this is what, when you're done, this is the direction that I went. And it says rewrite each expression. Hopefully you go through and you read the directions very clearly so that you understand what they want you to do. They want you to write it a different way, an equivalent expression, which means algebraically equivalent. Yeah, I mean, basically it's saying rewrite this in a different form. Well, the first one's easy, right? I mean, that's review from stuff we did the very first week of school, and it's review from last year. Number 2, though, did you notice this was x squared minus 25? That's called a difference of perfect squares. This is a quadratic, and we could factor it, if we wanted to, into 2 different expressions here. This is one of those that will give you square root of x will give you x, and the square root of 25 will give you 5 and negative 5. So number 2, this is how I rewrote it as a factored expression of x plus 5x minus 5, and you can multiply it out and double check me if you need to. And lastly, number 3, anything that's squared, I like to write it twice if we're going to work out problems. So 4w plus 2 times 4w plus 2. And then I'm going to double distribute this. Now maybe you did something different. As I said, we have different rules. And maybe you saw this differently, but I see it as 16w squared plus 8w. That's on the outside. The inside here, I get another 8w. And lastly, I get 4. Okay, so this, I could quit if I wanted to, because it just says an equivalent expression. And this is equivalent to number 3, to 4w plus 2 quantity squared. But most people, they just don't feel right leaving it like that. We got to go one more step here, and we'll rewrite it like this. So hopefully that brings back some of those past factoring skills and, writing equivalent expressions. Let's go to page 28 now. Odd one out. Consider the relationships shown by each of the given representations. So we have, I have some foreshadowing. Get rid of that. Foreshadow, be gone. We have 4 different relationships here. Now remember, a relationship is just when you pair x and y. Okay, so when you pair up x and y, you can do that on a graph. Check this out. I'm pairing up. Look, x is 4, y is 0. So I do have a relationship here. I have a relationship in this graph. Now I could do a little sketch of this, I guess. And I could make the graph that, relates to this table. Sure, if that helps us analyze these. Down here we have a relationship that's shown as an equation. And lastly, we have a word problem. Okay, now there are different types of functions in each one of these, and we need to kind of remember what a function is. So as I said, we hop around a little bit. We're on page 28 right now, but if I turn the page to page 29, I want you to look right here. It kind of tells you what a function is. A function is a relation such that there is only one, right here, output for each input. So remember, the input values are generally x, and the output values are generally y. Now sometimes instead of y, we use function notation. We say f of x. Here's how we would write that. F of x. And it means the same as y. They're interchangeable with each other. If we go down the page here, there's a nice little summary right here, reminding you that a relation is just mapping input and output values, or in other words, x and y values. That's where a relation is. And if every input has only one output, then we call it a function. And then function notation is read f of x. That's some good review. Now, as I said, we like to hop around in the book a little bit. So let's go back to page 28. Now that we've looked at all of those definitions, and what do they want us to do here? Consider the relationships shown by the given representations. Okay, first we have a circle. And my little foreshadowing before, you saw that I had a line go down here. But the reason that we had that line, I was just looking at it and saying, you know what, self, if I draw a vertical line here, this can help me figure out if I have more than one output for each input. Say what? I'm going to say that again. The vertical line here can help me show, it helps show me if I have more than one output for each input. So the input value right here would be 4. What's my output value? I have one up here. That's on the circle. But I also have one down here. So using a vertical line or the vertical line test, that's something we use in algebra. It's called the vertical line test. If I take a vertical line and I pass it over any graph and that graph touches the line more than once, then we know it's not a function. This is just a relationship. It's not a special relationship that we call a function. Now let's look at graph B right here. I'm just going to do a little sketch because we have a table. That is a straight line. Worship that line. Here we go, -6, 5, that's up here. I'm going to do a rough sketch, right? So -4, -3, that might be like right here. And -2, -3, maybe that's like right here. 0, 5 is up here. And then 2, 21. Wow, that would be like way up here. So notice that we get this shape. This is kind of U-shaped, right? Me-shaped? No, U-shaped. Right, like this. All the way up. Okay, so see how we have a U. I'm trying my best here with my little fancy pen, but that U shape, if I were to take this vertical line and pass it throughout the whole graph, it would only hit once at every point of the graph. So I would say this is a function. I mean, based on what I see right now, it looks like a function. Relationship C, do you remember what that is? This is y equals mx plus b. If I were to graph this, we go up to the y-intercept, which is 8, right? So 1, 2, 3, 4, 5, 6, 7, 8. And then here's the slope, and -3/4 means you need to go down 3 and to the right 4. It's down because it's negative. That's going to give me some line that looks like this. Again, that would pass the vertical line test, so this would be a function. And lastly, this relationship, Zeke has one app on his phone when he buys it. Okay, way to go, Zeke. So when he buys it, boom, one app. Let's just start at 1. He downloads a different number of apps each week. It doubles until he has no more space. So we're going to double it, and then we'll double it again, and then we'll double it again. And then that gives us a graph that kind of looks like this. So we have different shapes of graphs. First, we have the circle. The circle one's weird. That's not really one that we encounter a lot in Algebra 2. But the other three we encounter all the time. We have this U, and that's called a quadratic. And one of the ways we can tell if we have a quadratic is by looking at the differences in a table. Let me show you a little trick. If you have a table of values, and you find the differences between the points, in other words, how far is it from 5 to -3? I would say you got to go down 8, right? To get from 5 to -3, you got to go down 8. And how far do you have to go to get from -3 to -3? You have to go 0, because it's the same, right? And how far do you have to go to get from -3 to 5? 8. And then lastly, 5 to 21 is 16. Well, you might not notice a pattern yet, but if we do that same thing to our differences here, how far is it from -8 to 0? Well, it's just 8 up. It's positive 8. You go up 8. And then you do that from 0 to 8. It's up 8. And then you do that from 8 to 16. It's up 8. Do you notice how the second layer of this, or the second level, we get the same number? This is a little trick we can use to find out if a relationship is quadratic. So we're going to write quadratic right here. And you know that quadratic relationships form a U, right? But here's a little trick we can use to test whether a relationship is quadratic. Find the differences again. And guess what? If it takes 3 times, it wouldn't be quadratic, it would be cubic, which means an x third. The equation would be x to the third in some way. If an equation is in the form of y equals mx plus b, and there's no exponents on that x, then this will be what we call linear. So let's write down linear. That's a different family here. We have quadratic, we have linear. Obviously we know linear means it forms a straight line. And then if there's some multiplying going on, in this case it's doubling, so it's multiplying by 2, that's going to give us a curve that is called exponential. Okay, that's a different family. So we have 3 families of functions that are really important. The quadratic, the linear, and the exponential. And then sometimes we get weird ones like the circle. The problem with the circle is it's not a function. We talked about that. So there's no family of function for the circle because it's not a function. Oh my goodness. So your job right now, choose the relationship that does not belong with the others. Pause the video, choose the relationship, but you have to justify your choice, which means you have to give a reason why. Which one of these is different than the other? Go. Okay, so here's some of the answers that I got. Relationship A is the only one that's not a function, and relationship B has that constant second difference that I showed you with that table. Relationship C is a line, and it's decreasing. It's the only one that's decreasing, and relationship D is increasing over the entire domain. And it's the only one who's known to be discrete, although that table can be discrete too. What does discrete mean? It means we have single points and they're not connected with a line. And you know, this table right here, we connected it with a line, but I guess they're just saying each week it should be just a point. I don't know. You could use any of those rationales, but you know, I kind of favor relationship A as being different. You know what I'm saying? All right, so we're going to move on to page 29, which we kind of looked at it before. We're going to talk about equivalent representations. So if you look at not only page 29, but we go on to page 37 and 39 and 41, you'll notice we have a whole bunch of functions here, right? They're all mixed up, 39, 41. You just have these pages of functions. If you want, you can cut them out. You don't need to cut them out, but your job is to put them into groups that are equivalent. Now, how are you going to do this? Well, sometimes we have a graph here, and sometimes we have an equation, and maybe we need to see which equation matches each graph, and maybe which equation matches each table. Do these match up? If you want, you can use your calculator. Check this out. Here's our calculator. If you remember, if you hit y equals, you can type in an equation. And I don't know if you knew this, but you can hit the graph button and it'll show you what the graph looks like. Check that out. So this one here, D, I'm gonna look for that graph. Let's look for that graph. D looks like this. Let me pull it over. This is what D looks like. So I'm gonna go down my graphs. Is that this one? No, no, no. Look at that, T. So I know that that matches up. So D and T match up, right? And here's the spoiler alert. One of these tables, what? How do we do tables on a graph? Go back to your equation, type it in, go to the tablet button. So second tablet, check this out, 0, 5, 1. I'm gonna put that down here too so you can look at it. Use that graphing calculator to help you figure out which of these tables, let's see, what am I looking for? 0, 5, 1, 12, 2, 21. Are any of these tables that? 0, 5, 1, 8. You have to go through and you have to find it. 0, 5, 1, 12, 2, 21. W, I found it. So see how I'm making groups of equivalent. Now some of these you have to read the word problem and see which one matches up with that as well. But that's it. That's what your homework is. That's going to be the practice. So we're talking about practice. That's what we're talking about, practice. What you need to do for your practice is you need to group all of these equations. Make sure you're paying attention and you're asking questions while you're doing it because you're going to have a mastery check that is basically that, grouping equations. And that will basically conclude our first lesson, well, the first half. I'm going to make another video, we'll do the second half. But group it up and check your answers and then you can take a mastery check. This is Mr. Kelly K. Remember, it's nice to be important, but it's more important to be nice. See you!